Whenever tools come in contact with material, some type of dust is usually produced. We see this so often, we usually don't give it a second thought, simply because in most cases, the dust seems of very little significance other than being a nuisance. Unfortunately, this is not always the case, as in certain circumstances, airborne dust can result in a flash fire and even explode. This training explains what circumstances are dangerous, what is being done about it, and what we are looking for you to do. Naturally, we all know wood will burn, yet we don't ordinarily think of wood dust as potentially causing a flash fire, much less an explosion. In certain circumstances, a cloud of wood dust could behave as if it was flammable gas, able to cause flash fires and explosions. These flash fires and explosions of wood dust have caused extensive damage, injuries, and even death. The reason why wood dust is so much more dangerous than solid wood is the ratio of surface area to fuel. Oxygen is the factor required to accelerate burning. Suspension or a wood dust cloud is necessary for a flash fire or explosion. This allows a high rate of burn, as the wood dust particles are continually exposed to ample volumes of oxygen. Looking at the opposite situation, embers smolder in a pile of wood dust simply because they cannot get enough oxygen to burst into flames. To put it another way, have you ever tried to light a log on fire without using kindling? It is almost impossible. Yet, starting with the same amount of wood in 1-inch diameter kindling instead of a 6-inch diameter log, a much greater surface area to fuel ratio starts much more easily. A 6-inch diameter by 1 foot long log will burn for a few hours. However, the same volume of kindling with a higher surface area to fuel ratio will burn for a few minutes. The same weight of wood as a cloud of fine dust, a few thousandths of an inch in diameter, has a huge surface area to fuel ratio and will burn in less than a few thousandths of a second. This is the type of dust typically produced by sanding operations. The fine dust contained in a 6-inch diameter, 1 foot long log, if distributed as a dust cloud and confined in a space about the size of a 2-car garage, if ignited, would level the adjacent house. Our plant has one of the highest concentrations of burnable dry wood in the industry. Therefore, to prevent our workplace becoming the next sad example of a dust explosion, we must recognize the hazards and do what needs to be done to handle this issue safely. This can only be achieved by understanding the circumstances leading to wood dust explosions and what needs to be done to work safely. Most of the information in this training comes from the work of the National Fire Prevention Association and OSHA. So, what are the circumstances that lead to wood dust flash fires and explosions? The fire pentagram illustrates the components of fires, flash fires, and explosions that we need to know to ensure we do not have fires or worse. Fuel for us is wood and panel products, including dust. About 21% of the air is oxygen. Ignition is a process of enough heat to get the oxygen and fuel burning. This could be from a spark or flame, or even the heat from friction. A flash fire requires the dust to be dispersed as a cloud, creating a very high surface area to fuel ratio. Finally, the dust cloud must be contained within a structure, such as a building. Even a volume as large as our plant can explode, as flash fires could create pressures beyond the structural integrity of the building. As a start, dust is tested to see how easily it will ignite and explode. This information is then used to design the safety systems, focusing on prevention, containment, and recovery of any fires that do occur. We will now review each component of the fire pentagram, along with the steps to work safely. In our case, of course, the fuel is wood dust. We need to keep wood dust where it belongs, using the dust collection system every time dust is produced. We must ensure dust hoods are tight and there is ample extraction to capture all the dust. Address any escaping dust in a timely manner, including facilitating cleanup and the repair of any defective equipment. Most importantly, deal with accumulation of dust with routine and regular housekeeping. As a rule of thumb, if the color of the surface cannot be seen through the dust, there is too much. This ongoing housekeeping is essential, as most destruction and fatalities are a result of secondary dust explosions. This occurs when accumulated dust is disturbed by an initial explosion, creating further dangerous clouds of dust. As oxygen is 21% of the air we breathe, there is little we can do to reduce the hazard of oxygen. Therefore, the focus is on reducing the other hazards. Wherever possible, we must avoid and minimize all potential sources of ignition, sparks, heat, and hot work. An electrical spark can be static. A person walking in non-conductive shoes can create enough of a spark to ignite a dust cloud, or arcing, like a contact that is burnt. We need to make sure everything is grounded and bonded to dissipate any potential electrical sparks and that people are in conductive shoes so static charges are not generated. Electrical equipment needs to be appropriate for the area and checked to ensure it is in good condition. Electrical cabinets must remain sealed from dust and regularly inspected. All personnel must be on the watch and report any observed sparks. Mechanical sparks are generated by metal-to-metal contact, such as a rotating tool hitting a guard. Therefore, especially when we are cleaning and inspecting, we must look for and immediately correct any loose guards. Further to this, wherever possible, we must make the changes required to ensure it is next to impossible for guards to contact tools, such as never using expanded metal to make guards. High heat is usually generated by loose electrical connections, overloaded electrical circuits, hydraulic system restrictions, or friction. Friction includes worn bearings and the overstressing or overworking wood panels, either from insufficient heat dissipation or the flexing the material. High heat is best detected by operators being aware of their equipment, especially while cleaning and inspection, being careful to note any unusual heat, odors, or noises. Our maintenance program must also make use of thermal imaging and amperage readings to ensure equipment is operating normally. Hot work is surprisingly the fifth most common cause of dust fires. This is the work only occasionally done, such as when open flames are used to thaw pipes. Hot work also includes the heat of welding and the creation of sparks, such as when grinding and cutting. An authorized hot work permit is required any time hot work is to be done. This requires many things, including nearby fire extinguishers, the cleaning and wetting down the area, and posting a fire watch. Dispersion is the creation of a wood dust cloud. This cloud could be the result of a burst of compressed air, wind entering the building, holes in the dust collection, aggressive sweeping, or even excessive forklift speed. Obviously, some dust will blow around. It is when the dust cloud gets so thick that a thumb cannot be seen at the end of a fully extended arm. It is dangerous. However, to minimize the danger, we minimize the dust by not letting the dust escape from where it belongs. This requires the ongoing diligence of us all, but especially the operators and maintenance staff. We are counting on you to quickly resolve any dust escapes and minimize any accumulation of dust. The cleaning up of wood dust is best done with a vacuum first, followed by gently sweeping to limit dust dispersion. Small pockets of dust and dust on clothing can be removed with an air gun not exceeding 15 pounds per square inch. An explosion can result from a flash fire with sufficient fuel and oxygen to burn. So rapidly the pressure produced exceeds the strength of the structure in which it occurs. Hence, a wood dust explosion could blow our building apart and the roof could come crashing down. Therefore, eliminating the fuel by limiting dust accumulation with effective housekeeping is critical. Consequently, our focus is keeping the dust where it belongs, controlling sources of ignition, and not creating dust clouds. The dust collection system is our key to keeping dust where it belongs. Therefore, it is critical the system and collection hoods are well designed and maintained. Hoods must surround the cutting point and direct the airflow. The aperture must be of a size to ensure the airflow is fast enough to grab all the dust. Larger wood particles are easier to grab than smaller ones. Therefore, the dust that escapes is often too small for the eye to see. Consequently, operators and maintenance staff must be diligent in ensuring the dust hoods are always installed and operate correctly. A well-planned and practiced emergency procedure could prevent a minor fire from becoming a major disaster. If a fire breaks out, your actions are critical. Raise the alarm. Do not put yourself at risk. If the fire is severe, contact the fire department. If the fire is within your capability, use the available firefighting equipment. Ensure you always maintain at least 2 safe routes of escape. Attempt to direct the fire away from materials that would spread or intensify the fire. Avoid creating a dust cloud by using a fog nozzle or an extinguisher suitable for electrical fires. After a fire, follow the documented recovery plan to as quickly as possible resume shipments to customers. We also need to evaluate and understand what happened so we can prevent it occurring again. This concludes this training on what we are doing about the dangers wood dust flash fires and explosions. Please see your supervisor if you have any further questions or concerns. Thank you for your attention.